Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to electromagnetic theory, and so far we have discussed various concepts related to basic concepts related to electromagnetic waves, and in the previous video we discussed just the introductory concepts related to electromagnetic spectrum. So here we will just try to cover it in a little bit of in a detailed way, not lengthy, but we'll try to cover it in a quick way, covering all the basic aspects, touching the important points related to it. So first things first, electromagnetic spectrum is basically the categorization or classification of the whole range of electromagnetic waves on the basis of their frequency or wavelength. We discussed the important elements of an electromagnetic wave, that is amplitude, frequency, phase, wavelength, time period, speed, and their interrelationship. In the previous video, you can watch it. So basically, electromagnetic spectrum is the orderly arrangement of the electromagnetic waves on the basis of the two important properties, frequency and wavelength, which are interrelated with time period, speed, and that. Okay, so on the basis of that, we just had a quick look at this, which is the electromagnetic spectrum on the basis of frequency range in the unit of hertz and wavelength range in meters. So here we'll be discussing each of these sections in a quick way. So first is gamma rays with frequency range from 10 to the power 20 to 24 hertz, and wavelength range is lesser than 10 to the power minus 12 meters. So that's the first. So gamma rays, they were discovered by Rutherford. So they are of very short wavelength, extremely short wavelength. In terms of wavelength, it is the lowest. It is 10 to the power minus 12 meter, and anything less than that. So that comes under the category of gamma rays, and they are emitted from the nuclei of radioactive elements because of radioactive decay. So some basic properties of gamma rays is they are highly penetrating in nature. They can penetrate substances with covering greater depths as compared to the other electromagnetic waves. They have a very small ionizing power. So ionizing power is basically that when certain electromagnetic radiations are focused on specific materials, they cause it to lose electrons. They force it to lose electrons, causing chemical reactions, and as a result, certain chemical changes take place. This is called as the ionizing power or ionization of power of the electromagnetic waves. So on the basis of that parameter, the gamma rays, they have this property in very less amount. They don't possess that, they don't cause ionization to that extent. So they have small ionizing power, and they affect a photographic plate also in a small extent. So basically, again, photographic plate is basically a light sensitive material consisting of silver salts which are mixed with certain gels to form an emulsion, and a coating of it is placed, it is spread on a plate of specific shape, size, which can be customized according to requirement. So when an electromagnetic wave or ray is focused on it, particularly light rays, they are focused on it because light is also a form of electromagnetic radiation. So when it is focused on it, certain chemical reactions take place on the light sensitive material. So certain portions, they allow light to be transmitted, while certain portions, they block it. So this blocking and transmitting of light also happens in varying extent, varying quantities at different places. So a pattern is formed on the plate. Okay, so this is basically electromagnetic ray affecting a photographic plate. So gamma rays, they also affect a photographic plate, but to small extent. And then they are not deflected by electric and magnetic fields. So whenever it is passed, or the gamma rays, they are focused through a medium where there is both electric and magnetic field, they pass undeviated. And they also produce heating effect, some amount of heating effect on the surface on which the gamma rays are exposed. So these are some of the basic properties. There are a lot of other properties, but here we are just trying to cover them in a quick way, the basic important points we are discussing. Then these are the properties. Then uses of gamma rays. So there are many applications, these are just to say a few. They are particularly used in the treatment of tumors and cancers, that's the biomedical applications in humans. But this procedure has to be done with very, with taking care of much accuracy and precision, because these electromagnetic rays, they can also attack and damage the healthy cells of the body along with the tumor cells or cancer cells. So they can also cause damage. So that's why there's care should be taken while performing this procedure. This is one of the disadvantages also. And they are also used to detect cracks, flaws in metal castings and other structures, civil structures where metals are used. So these are used for a transmitter and a detector. Gamma ray transmitter and detector are placed, and depending upon the reception at the receiver side, the intensity of the gamma ray at the receptor side, so the nature or shape of the flaw or crack, that is estimated. And they are also they're used to produce nuclear reactions. So these are some of the uses of gamma rays. So first thing, the first category, gamma rays, is covered. Next is X-rays. The frequency range from 10 to the power 17 to 10 to the power 20 Hertz, and wavelength from 1 nanometer to 1 picometer. So X-rays were discovered by Wilhelm Röntgen in 1895, and their wavelength, it ranges from 1 nanometer to 1 picometer, and they are produced by very fast moving electrons which are stopped by a heavy metal target. This we have also covered in the engineering chemistry section also. But okay, this is the basic thing. They are produced by very fast traveling electrons which are suddenly obstructed by a heavy metal obstacle or target. So the basic properties of X-rays, the same, you will find the same thing. First, they affect the photographic plate very intensely, high as compared to the gamma rays, which means the intensity of the pattern which is formed on the photographic plate, that is very high. Then same, they are not deflected by electric and magnetic fields similar to gamma rays, and they ionize the gas through which they are passed, or the material through which they are focused on, to a much larger extent as compared to gamma rays. So here, affecting the photographic plate, it is higher as compared to gamma rays. Ionization property, it is higher as compared to gamma rays. Only similar thing is both gamma rays and X-rays, they are not affected by, they are not deflected by electric and magnetic fields. So if X-rays are also passed through a medium where both electric and magnetic fields are there, they will go undeflected, undeviated. Okay, see, these are the basic properties of X-rays. Then uses of X-rays, we all know one popular use, common use in biomedical application is to produce pictures of the internal organs of the body. So X-ray scanning, okay. Same thing, they are also used for the treatment of tumorous and cancerous cells in the body. Same thing, care should be taken because they can also cause some damage to the healthy cells. They are also used to detect flaws and cracks in metal castings and to study the structures of crystals and arrangement of atoms and molecules in a complex substance. This is particularly used in material science engineering. Before the choice of materials is taken into consideration, this technique can be used to study the behavior of the materials. So then is after X-rays we have ultraviolet rays or UV rays with frequency range from 10 to the power 15 to 10 to the power 17 Hertz and wavelength range from 400 nanometer to 1 nanometer. So ultraviolet rays, they were discovered by Ritter in 1801 and their wavelength range is from 400 nanometer to 1 nanometer as we saw in the electromagnetic spectrum table, and they are produced by one of the most which we see example of ultraviolet rays production is the sun, which produces a large amount of ultraviolet radiation, most of which is absorbed by the ozone layer in the upper layer of the atmosphere. Other sources are carbon arc lamp, electric spark, discharge tube, mercury vapor lamp, hot bodies and sun obviously. So these are some of the sources of ultraviolet rays. Again, the same thing, the same properties. First, the nature of affecting a photographic plate. The UV rays, they affect a photographic plate causing patterns on it. Then ionization power, they cause, when they are focused on particular substances or materials, they cause it to lose electrons and promote chemical reactions. And another important thing is they cause fluorescence. Fluorescence means that when UV rays are focused on a material or substance, it causes emission of light from that substance because of certain chemical reactions. This property is called as fluorescence. In certain materials, UV rays can cause this property of fluorescence. Okay, so rest are the same thing, the same properties, and when they are allowed to fall on certain metals, they cause emission of electrons. So these are some of the basic properties of ultraviolet rays. Then is use of UV rays. So ultraviolet rays, they are used for checking mineral samples, and based on the property of fluorescence under ultraviolet radiations, and also on the property which is here, the ionization property, and their ability to affect the photographic plate, they can be used to check the mineral samples. Again, it is helpful in material science engineering and other applications also. Then they destroy bacteria and other microorganisms, and hence they are used to sterilize surgical equipments, medical equipments and other things. And they are also used to study the molecular structure of materials. So these are some of the basic uses of ultraviolet rays. There are others too, many applications, other applications. So here we have covered ultraviolet rays with the basic concepts, properties and uses. So here we have discussed first the gamma rays, then the X-rays and the ultraviolet rays. So in this video we will cover only that. In the next video we will be covering the other bands or other categories of the electromagnetic spectrum. Okay, so I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.